Simple and compound interest. Interest is the amount of money paid or earned for the use of money by a bank or some other financial institution. So when you take a loan out or something, then you would have to pay interest on that loan for borrowing that money. So you also have to pay back whatever the interest is. Simple interest is paid online on the initial principal. So it's what you originally borrow of a savings account or a loan. So we have an equation that we use when we talk about interest, and that equation is that I equals P for our principal, and then R for our rate, times T, which is our time. So let's just go ahead and label those. So we have our time, and time is always going to be in years. Then we have our rate, and our rate is always going to be in a decimal form. And then we have our interest, or our principal, which is that initial money borrowed. So this is the principal, which is that initial amount. And then obviously I is going to be our interest. And this is going to be the equation that we remember and use throughout the rest of the time when we work with interest types of problems. So we're going to find the simple interest to the nearest cent. So on the top of my paper, I'm just going to write that I equals PRT, just as a little reminder for when I go to solve these. So when I remember this, I'm going to find the interest. So I know that I'm going to be searching for I. And that is equal to, and I'm just going to write that in a different color just so that we can see it better. So I equals, so the principal, so we have $1,000 at 0.45%. So I need to just write that percent as a decimal. So to do that, I would move my decimal point over to the left 2 places. So I get 0.045 times my time, which is in years, times 2. And all I'm going to do is I'm going to multiply that together. And when I multiply that, I get that I equals 90. So the simple interest equals $90. So if you borrowed $1,000 and you plan to pay it back in 2 years at 4.5%, you would have to pay that $1,000 back plus the $90. Go ahead and pause the video, and I want you to try the next one on your own. So we have that I equals my principal of $2,500 at, the decimal is 0.0675 times 3. And when I multiply that together, I'm going to get that the interest equals $506.25. Mr. Gable borrowed $180 to buy a computer. He will pay $71.30 per month for 30 months. Find the simple interest rate for his loan. So when I see this interest rate, I'm actually solving for R. So the very first thing I need to do is I need to find the interest that he paid. And to find the interest that he paid, I can take 71 or $71.30 times 30. Because this is going to tell me how much he paid total. So after all of his 30 months of payments, how much money did he totally spend? So $71.30 times 30 gives me $2,139. So he paid a total of $2,139 after all 30 months. But I still don't know the interest that he found or that he paid first. So to find that interest, I'm going to take that $2,139 and I'm going to subtract that from that 180. So 2,139 minus 180 is $1,959. So his interest actually was $1,959. So the next thing I need to do is I can solve for R using that interest equals the principal times the rate times the time. So I'm just going to substitute what I know in. So that I equals that 1,509 equals the principal of 180. I don't know what the rate is. And the time, remember, always is in years. And 30 months equals 2.5 years. So 180 times 2.5 equals, so I have 1959 equals 450R. I'll divide by 450. When I divide by 1,959 divided by 450, my rate is 4.35. So I need to move my decimal over 2 places to find my percent of 435%. Suppose Natalie placed $2,400 in the bank for 5 years. She makes $9.20 of interest each month. Find the annual interest rate. So I need to find how much interest did he actually make on the total amount. So to do that, I'm going to take that $9.20, and because that's each month, and this is in years, I need to figure out how many months are in 5 years. Well, there are 60 months in 5 years. Then I'm going to take $9.20, and I'm going to multiply that by 60. And I get that she made $552. So I'm going to add that to the original $2,400 because that's going to tell me the total amount that is in the bank. To find my annual interest, I'm going to do that I equals P so my interest was $552 equals my principal times my rate times my years. So I have 5. So I'm going to get 2,400 times 5, which equals 12,000 times R. When I divide by 12,000, I'm going to get 0.046 equals R. And since I want that into a percent, I'm going to move my decimal over 2 places. So I get 4.6% was the rate. Compound interest is paid on the initial principal and then on the interest earned in the past. So let's take a look at what compound interest looks like. So what is the total amount of money in an account where $600 is invested at an interest rate of 8.75% and it's compounded annually for 2 years? And this compounded annually is very important to see because it's letting us know that we're going to do it twice. So the first thing, I need to find how much was made on that original first year, so year 1. So I'm going to use I equals P times R times T. So I'm going to get that I, because I don't know what the interest is right away, equals my principal is 600 times 0.0875 times 1, because it was for 1 year. So 600 times 0.0875 equals $52.50 is my interest. So I'm going to add that because after year 1, so I put in my $600, and I'm going to add that to what I just had interest for that first year. So I get $652.50. So that's what's in my bank account after the first year. But our question tells me that I'm compounding for 2 years. So now I need to do it again. So my interest equals my principal, so what's left in my bank account, so that's $652.52 times that rate, and this is just another year. So now my principal had changed because I'm compounding it on that original one. So I have $652.50 times 0.0875. And I'm going to get $57.10, and I'm going to add that to what was in my bank account. So that's $652.50. And I get a total of $709.59. Go ahead and pause the video, and I want you to try this one on your own. After you have tried this one on your own, I want you to bring this problem back to me in class, and we're going to check it together to make sure that you solved it correctly.